And no, I do not need a boat. I don't want your boat. Here we go. The informal definition of a limit. Today is not confusing, but it is new to you. It will take us a little bit to get through the notes. I apologize. I wish that it was a shorter day, but we have material we have to cover, and unfortunately, you don't know any of it yet. We need to disseminate that to you. So the informal definition of a limit. It's just kind of an informal expression of what it means, which means we are going to have a formal way of saying it that is much more complicated. But this literally reads right here, it reads the limit as x approaches a of the function is equal to L. That's what it literally says. That's how we would translate that mathematically into grammar. Okay. So we have to learn how to speak mathematics so we can read it as well. So I have some students that when they see that they say 2/3. I get it. We could say 2/3. Sometimes if people see that they don't say 3 squared or 3 to the second power. They say 3/2. No, don't, don't don't say that. Okay, let's speak correctly. So here's what it means. As x values get infinitely close to a, the y values get infinitely close to L, L being the limit. So in your work the past few days, when you've been finding the slope for those tangent lines, you have been finding a limit. What we need to do now is take a closer examination into what limits actually are. And we're going to use our calculators to do that. First of all, this is a quadratic, and it makes this type of shape. Okay? I'm going to look at, as the x values get really close to 2, what do the y values get close to? So that's the big question that we have here. X is getting close to 2. What are the y values getting close to? So I'm going to take out my calculator, turn it on. I'm going to go into y equals, and I'm going to type in 0.5 x squared. What is it, minus 2x? Minus x plus 3. And go into my table. And I want to get really close to 2. Give me some numbers that could get me close to 2. 2.1, thank you, Jake. 2.01, 2.001, so on and so forth. Anybody want to make a guess about what? These are trending towards 3. Thank you, Rachel. Now, but hold on. This is an important step that we're making today. Did I approach from the right or did I approach from the left? I approached from the right. I also want to approach from the left and see if I get the same type of results. What numbers can I? Thank you. So Emma has a great idea. 1.9, 1.99, 1.999. And would you agree that those are going to 3 as well? Okay. So it seems quite obvious after looking at our data that we are definitely approaching 3. Now, what if I just type in 2? Well, I get 3. Yeah. Now, that didn't work before. Why? Because if x was going to 1 here, it was undefined in the, for values of that x value, right? So it didn't work in that situation. In most cases, with most functions, you can simply type it in, and it will give you the limit. Okay? And we'll do that example right here. The square root of x plus 4, what does that look like? Yep, very good. Shifted to the left 4 units. And it's going to have a y-intercept of 2. Because if I plug in 0 for x, I get 2. Yes. we plug in 2, we get 3. Yep. Yep. We said that. It's okay. You're helping Ty. I get it. Okay, here we go. So, all right. What is the x value approaching? 0. Let's plug in 0. The square root of 0 plus 4 is 2. And sure enough, if you look at the graph, it is approaching a value of 2. So the limit is 2. All of a sudden, you're like, well, this is really boring. We're just plugging in values. Well, we have a lot of equations where it doesn't work out like that, where it's much more complex. For example, look at letter C. We have the limit as x goes to 3 of h of x. Can I plug 3 in there? If I plug in 3, what do I get in the numerator? I get 0. What do I get in the denominator? 0. Now, Kelvin said something really important. Thank you for bringing it up. If you take 0 and divide it by 2, what do you get? 0. But if you take 2 and divide it by 0, you get... This is different. This is 0 divided by 0. We don't know what the heck 0 divided by 0 is. In fact, we will have a unit of study on that in this course. It's an indeterminate value. But we're going to show you what 0 divided by 0 is going to end up being. And I'm going to just pull a little trick here. I'm going to rewrite this expression, h of x. This is possibly the most important problem of the day, that we really understand this. X times x minus 3 all over x minus 3. What happens? Cancels out, and there's just an x. Now, let's get to that. Right now, you know that 3 doesn't work, right? Do you remember when we were graphing rational functions last year, when we saw that 3 gave you 0 in the denominator? Do you remember what that type of function had in it? A vertical asymptote, right? If it divides off, it's not an asymptote. It's something else. It's just a blank spot. Okay? So it looks like this. As Kelvin said, we get x. This wants to look like the graph of x, which is just a line with a slope of 1 that passes through 0. But when it gets to 3, it has a gap. If it divides off, it has a gap. Let's type that into our calculator so we can be convinced of it and then see what the limit is. We type in x squared minus 3x divided by the quantity x minus 3. This is super cool. Watch what happens. I'm going to zoom as a decimal, number 4. And when I zoom as a decimal, it makes every pixel up on your screen 1/10. So as you go to trace, as I move to the right, it just changes by 1/10 every time. Okay, so what do you notice about my graph? Yeah, there's a gap right there. So as the x value gets closer to 3, what's the y value getting closer to? It's getting closer to 3. Oh, what happens when I go 3? Nothing. There's a gap. Right. Michael, you said it perfectly. 3 is not in the domain. 3 is not in the domain, so there is no y value if you plug in 3. But the limit, listen to this, the function does not have to have a value there in order for the limit to exist. The idea is, what are we approaching? As you get closer to 3 this way and get closer to 3 this way, what does the output get closer to? It gets closer to 3. So the limit is 3. You don't have to have a value in order for the limit to exist. Do you guys have your worksheet from yesterday? Can you please take it out? Okay, I gave you a function. What was the function? X squared plus 2. What was the x value? X value is 1. the point on the line then was 1, and when you plugged in 1, what did you get? -3. And so what you did was this. Watch what you did, and the aha moment should happen. You took x sub 2 minus x sub 1 divided by x sub 2 minus x sub 1, right? This is undefined. At what value? So you might say, oh, it'd have a vertical asymptote. It doesn't have a vertical asymptote. It just has a gap. What'd you come up with for the slope? Look at this. This function wants to look like x minus 5. What happens when you plug in the 1? Some of you guys figured that out on your own. Some of you guys didn't. But that's where we're moving. Every time you find the slope of a tangent line, here's what's awesome. There's always a gap that exists that we're trying to fill. That's it. And that's the big idea. Let's look at a more challenging function, okay? Let's look at a more challenging. Let's try this one, because I just showed you a little bit of fancy algebra, right? Things don't always work out with fancy algebra. What if I plug in 0 here? What do you get? I mean, who knows? Well, let's look at the graph. So I'm going to type in sine of 1 over x, and you should always be working in radians. But I'm going to adjust my window, okay? First of all, zoom standard. And I don't really like what I see. I hardly see anything at all. But I can help myself out a little bit. If I go to my window, what's the largest y value that you can have? I have 1. And what's the smallest y value I can have? So I'm going to go -2 to +2. I'm going to look at that graph. Oh. Okay. As I get closer to 0, can you see where the graph is going? I can't tell. I'm going to zoom in. Can you tell now? Can you tell now? You're saying 0. He said 0. You still, oh wait. I'm still not convinced. It looks like a barcode, doesn't it? It's actually called the barcode function. It's really hard to tell where that limit is going, isn't it? Like as x gets close to 0, what's the y value doing? I'm so confused. Yeah, what's the y value kind of closing in on? You can't tell, can you? What if we looked at the table values? What values could we punch in? We'll do this when we get back. Okay, here we go. So I'm going to look at it. Here's my graph. We already talked about the barcode function. If I go second table, I'm going to approach 0. Let's approach 0 from the right. What values can I plug in? 0.1. Now, careful there, okay? He went to straight 0.001. A lot of people in second hour especially, they were saying, well, just go 0.0001 right away. We'll give you the answer. We have to look for the trend. Okay. I would suggest to you guys that there is no trend here. you can continue to type in more values, 0.000001, and you're never going to come to a spot there. Let's try to approach it from the other side. Negative 0.1, negative 0.01, negative 0.001. Yeah, we're getting those same values. Is it ever? They're just opposite. They're never isolating in on a specific value. So if they won't come to a specific value, then we say that the limit does not exist. This is the first group, first year. You must be that far removed from the movie scene, but anybody see Mean Girls? The limit does not exist, okay? And every other year people have shouted that out, and so we must just kind of be at that time, at that age frame where it doesn't work out. So in order to talk more about limits, we have to talk about one-sided limits and to determine whether they exist or not. And we use some special notation. Note this symbol right here, okay? There's a negative sign above the A value. That means that we're going to approach from the left. If you see the plus sign above it, that means you're going to approach from the right. So we call these one-sided limits. In this situation, it approaches A from the left, and in this situation, it approaches A from the right. All the limits on the previous page are two-sided limits because it does not delineate plus or minus after the number. So look at this one, Calvin. It says limit as x goes to -4 from the left. That's how we interpret that. Limit as x approaches 4 from the left of the function. So here's my function. I'm going to approach 4 from the -4 from the left. Now, what is the output? What is the y value approaching? 3. Now, if I plug in -4, do I get 3? Yes. Let's move to the next one. Now I approach -4 from the right. What is it approaching? It's approaching -2. If I plug in -4, do I get -2? No, I get 3. So it's what it's approaching, not just what you get when you plug it in. Look at -1 from the left. 4. -1 from the right. 4. If you plug in -1, do you get 4? Yes. So if I ask you what is f of -1, if I plug in -1, what is the function value? The function value is 4. The function value at -4 is 3. Okay? Let's do a different one, though. Let's go to 2. 2 from the left. Very good. -1. 2 from the right. 5. If I plug in 2, what do I get? You get the -1. Okay? Yeah, and that's why you get that value. Exactly, because of the open and closed circle. So this is the question. What is the limit then as x approaches 2? Do you see a one-sided limit here? No, this is two-sided limit. We say this does not exist. And the reason why is the left-handed limit is different than the right-handed limit. So this is a more formal definition for a limit. The limit exists if and only if the limit as x approaches a from the left of the function is equal to the limit as x approaches a from the right of the function, and that those are both equal to that limit. So a two-sided limit only exists if it's the same from the left and from the right. Here. The L, yeah, limit. What? We're going to do that right now. So now we're going to approach 4. Is this a one-sided limit or a two-sided limit? Two-sided limit. I approach from the left and I get 2. I approach from the right and I get, is that the same? So therefore the limit exists. If you approach from the left and the right and they're the same, then it exists. Please note, if you plug in 4, do you have an output? No. The function does not have to have a value there in order for the limit to exist. All right, very good. Let's look at these two, okay? It says, use a table in order to determine the following limits. We're going to plug it in. You're going to have to do this on your assignment today. We go to y equals, and we type in parentheses x squared minus 4 divided by parentheses x minus 2. Right? Is this a one-sided limit or a two-sided limit? Two sides. So I'm going to have to approach from the right and the left. Help me approach from the right. What should I plug in? 2.1, 2.01, 2.001. What does it appear to be approaching? 4. I'm going to approach the other way from the left. 1.9, 1.99, 1.999. Are you convinced? It is 4. Can I show you how to do it algebraically? To the top factor. Thank you, Spencer. X minus 2, x plus 2. So I could cancel that off. Now can I plug in 2? What's 2 plus 2? There you go. Now, in this one, you just like want to cross this off and say, well, we have sin. Okay, there you go. No, it doesn't work. Okay? It doesn't work. There's no tricky algebra here. You have to actually look at the data. So we have sine of x, and we're going to divide that by x. I will teach you later on in this calculus course how we can evaluate that limit, but it involves derivatives. It's a little tricky. But so we're going to go to our table. It's a two-sided limit. Approach it from the right. 0.1, 0.01, 0.001. Any thoughts? Yep, we'll approach it from the left. Negative 0.1, negative 0.01, negative 0.001. I'm convinced it is 1 according to our table. Okay, this will go very quickly. Suppose we want to look at the graph. Anybody know what 1 over x to the 4th looks like? Do you remember what 1 over x looks like? Yeah, very good. It looks like that. So if it's to the 4th power, that means it's even, so they're both going to be above, right? So it looks like this. If you don't know that, you can simply graph it on your calculator, folks, but this is what it looks like. That's my graph. What am I approaching? X is going to approach 0. From the left or the right or both? Both. Let's approach from the left. Thank you. How about from the right? Are those the same? Therefore, the limit is infinity. This next graph looks like this. It has a vertical asymptote at 1. This one had a vertical asymptote at 0. How did I know this had a vertical asymptote at 0? Because it's undefined at 0, right? And it doesn't divide off. Here, we have it at 1. So I'll approach from the left. What if I approach from the left? Negative infinity. How about from the right? Are those the same? No. DNE does not exist. To save time, we won't fill this out, but basically infinite limits, okay? If x approaches a, gives you an infinite limit, okay? What we know is that we have a vertical asymptote. What is the vertical asymptote here? To write an equation for a line, is it x equals or y equals for a vertical line? X equals. And it's x equals 0. What would it be here? X equals 1. So limit as x goes to a of the function equals infinity basically means that as it approaches that value, the outputs become exceedingly ridiculously large, okay? And so you know that you're going to have vertical asymptotes in those situations, and that's what we have, okay? So your assignment for today, it is a book assignment. What I will do is right after this class, I will go and I will